administration of Ganga Hospital, Dr. Rana, Dr. Arun Swarup, and my friend Anil Balla for giving me this opportunity to address this very august gathering here. Dr. Ajay Swarup actually told me, can you talk on AI in healthcare? I'm not sure whether I could talk on AI in healthcare because 5 years back, I was a total disbeliever in artificial intelligence. I thought medicine was natural intelligence, empathy for the patient, proper diagnosis and therapy. I believe that AI may not have a role. Since then, I've changed dramatically. The last 1 year, I think I've become a total convert to AI and what it can do in medicine. So let me start with a disclaimer that I'm not an AI expert. I just use some of the AIs like ChatGPT. I can't do algorithms, but I think some of the AI benefits I've started to realize in recent years. So when we are making a topic like this with your audience which is so educated, it's sometimes a difficult thing to do. I was a bit nervous, so I said, what should I do? So I used artificial intelligence for this. So I went to ChatGPT, and I told ChatGPT, I have this lecture of 40 minutes by Ganga Hospital on distributed guests. What should I talk on? And ChatGPT, that was my question. Can you help me? I said, of course. I was happy to help. Gave an introduction, technology in healthcare, NLP, application of AI in healthcare, challenges in ethical consideration, the future of AI in healthcare, and collaboration between AI and professionals. So this is going to be the background of my talk. And finally it said, should I make the slides for you? I said, no, I'll make it myself.
Same here, I also do the same.
So medicine has been, traditional medicine has been patient care using clinical examination, investigation, empathy, and natural intelligence. This is what we've been following for more than 40 years. There is a change coming in, and the change is how we are going to use artificial intelligence to harness what we're going to do in a better way. So for those who are uninitiated, and I expect that as 90% are doctors here, most of the time you're reading about artificial intelligence in newspapers or magazines here and there. You're not really gone seriously to this, as I had a year back. I did a course in artificial intelligence, and then what I'm going to do is to give you a brief initiation into this before we actually go into how at AIG we are using artificial intelligence to do better patient care. It was 1950, or actually it was the Second World War, that Alan Turing, a very famous British mathematician, started using artificial intelligence. He used it actually to decode messages which came in German ships which were traveling around UK. And he was able to do that very successfully. This was the first use of artificial intelligence, and it's believed that Britain won the World War II because of him. Not well recognized, but this was the case. In fact, there's a famous Alan Turing Prize now, which is given for a computer scientist, is equal to Nobel Prize, because Nobel Prize is not there for computer scientists, they give the Alan Turing Prize. In 1956, at a conference in Dartmouth, the term artificial intelligence actually was coined. And at that time, they coined it saying that what is artificial intelligence? It is actually a machine having the intelligence of human being. That was the broad term. And even now, we don't have a better term than this, machine having human intelligence. For the next 20 years, from 1956, it is what is called the winter of artificial intelligence. Nothing happened. Everybody forgot about it. It was only in 1980s that what came was machine learning. We developed the ability to put data into the machine and get answers. This was the machine learning, which was a very preliminary part of artificial intelligence. And then it was in 2010, and from then onwards came a major revolution in artificial intelligence called deep learning. Now what does deep learning mean? Deep learning means that not data into the machine, we are putting several layers of data into the machine. When you put several layers of data into the machine takes all this data, by itself starts synthesizing it and comes out with a single output. So this is deep learning, and this deep learning and what we use in medicine has dramatically changed how we actually use this. So till 2010, anybody who spoke about artificial intelligence were not somebody who were actually using it properly, but this has changed. In the last 2 years, there's been a dramatic change, just 2 years. I think if you look at many specialties in medicine, change will take many, many years, sometimes 10 years, 20 years. But in this 2 years, everything has changed completely. So artificial intelligence became machine learning became deep learning, and deep learning is what we are going to now study about. And again, before I actually go into how we use artificial intelligence at AAG, let me introduce into the 3 fundamental models of artificial intelligence. The first one is called language model. The first one is called the language model. Language models are what is called LLMs, large language models, which means you feed in large amount of data and artificial intelligence can synthesize and come out with an answer. You put all the papers on, say, pancreatitis into this and it will come out with various solutions. It also has papers on cardiology, nephrology, everything getting together and mixes it. Similarly, we have small language models. All these small language models for one specific disease. We can know everything about the disease, like fatty liver disease, everything about it using them. So this is LLMs, language models. And typical example is ChatGPT. I just told ChatGPT what should I talk, and you see it took all the data from different sources and gave me a nice synthesis of what I should talk. The second one is called computer vision, the second model. Computer vision is what the medical people have been using for very long. So what does computer vision do? Computer vision picks up a vision and then it says this is a polyp, this is a malignancy, this is a benign polyp and so on, or X-rays, it can read X-rays. All this comes under computer vision. And one of the unfortunate things we have been doing in medical practice for long was just depending on computer vision. All our concentration was computer vision. That's why it didn't progress further, because there's a lot of biological variability that has come. The third one is called the NLP, that is natural language processing. So you talk something, it gets recorded, types out, which we already had, but also does segmentation, which means you talk to a patient, it comes out naturally, present history, past history, and so on, segmentation. So this is NLP. So these are the 3 language models that artificial intelligence engineers have been using, and we as doctors should understand this before we go further on. So in healthcare, you see artificial intelligence is used in many, many areas. And before I go further, one area which is going to make a dramatic difference is in drug discovery and development. On an average, for a drug discovery, it would take about 20 years, 30 years, 40 years. A vaccine development would take another 20 years. But using artificial intelligence now, drugs can be developed in 2 years. Just 2 years you can get. So we're going to get a huge number of new drugs based on algorithms that can be made, because you know targeted drugs, where the target is, what type of drugs you can try it out on the computer model itself before going to animal work and then of course human. So the 2 years is for human work. Actual computation will take only about 1 week, 2 weeks, 3 weeks. And this is going to be a major dramatic change in how drugs are going to discover. We already have now early evidence that antimicrobial resistance, which has been a major problem, can now be solved completely with this new type of drugs. So this is going to be one of the important things. So artificial intelligence predominantly started with radiology, imaging, then went to disease diagnosis, and then to telehealth. So if you actually look at individual areas, for the clinician, it's going to help us with an accurate, rapid diagnosis. Health systems efficiency is improved, and of course for patient personal health. I'm going to give you examples of actually what we're doing with each of these at AAG. For last 1 year, we have started using this. We have employed 40 scientists, from engineers from Google, Microsoft, and so on, created what was one of the first AI Artificial Intelligence Institute in a hospital setting. And then we have done a lot of things which I'm going to show you as we go along. So when we started this, many of our junior doctors were very worried. They came and told me, you think AI will replace doctors? I said, no, AI will not replace doctors. But doctors who know AI will replace doctors who do not know AI. Ultimately, all of us have to become AI educated, because this is going to be something, it won't be predominantly what you're doing, but we have to have this knowledge. So this is extremely important as I go along. So let's look at the whole world of what AI and healthcare is doing, again with examples from our setup. So it can help in health service management. So how does it do this? For example, in our hospital, we found that optimization of operational efficiency is extremely good when you start using. And again, I'll show you. We can do supply chain optimization, and those who are administrators in Ganga would realize the importance of this. Fraud detection and compliance happens very commonly in hospital, drugs missing and so on. This can be completely cut off with AI, and of course, integration of care across providers. So what we have done as a part of efficiency in AI use is creation of this. This is Mira. This is a robotic system which we made. We call it the Mira, which helps us in a variety of ways. And let's see what Mira says.
Hello, everyone. I am Mira, the medical information robot at AIG Hospitals. I am your future healthcare companion and here to change the way we think about healthcare. I have been meticulously designed to assist doctors, empower nurses, and most importantly, ensure that patients receive information in a faster and better way. I will assist patients and healthcare professionals, but never replace them. My goal is to enhance patient experience with human oversight, and in the future, with appropriate training, my role may increase for evidence-based circumstantial requirements. I look forward to learning from the clinicians' experiences to continuously enhance my skills in the field of gastroenterology and other specialties.
So what we did was we created a number of Miras in all our OPD departments. And Mira is fed with all the knowledge for lay people and for doctors. For example, when I see a patient, I take 20 minutes. About 5 to 10 minutes is spent in explaining things which I don't have to the doctor. So many tablets you take it after food, take it this thing, this can occur, this complication, all those things. All this is taught to Mira. So I tell, okay, after I see, go and see Mira, Mira will tell you about the things. So Mira will tell the patient all those things. Nowadays, people have got so used to Mira that my patient, after he sees me for 10 minutes and say, rest of the information I'll go and get from Mira. Why? Because Mira is talking very clearly and Mira is better looking than me. So therefore, they tend to go to Mira. So Mira. The second use for Mira is we found for our junior doctors. We feed Mira with a lot of data. There are now 10,000 articles of complications of ERCP. Mira is fed all those things. So when junior doctor comes and tells me, look, we did a ERCP, there's a perforation of the liver capsule, are there any reports? Mira immediately will come out with a report. Yes, in gut last year there was an article published on this. So these are the two areas. So medical informatic robotic systems, that it's called, has been extremely useful in transforming our practice so that we can spend more time with the patient rather than talking. And then of course for the residents also it's quite interesting to interact with Mira. The second important thing we did, and this is again very interesting, is called the iSave software. Now what is this? What happens in a hospital? We have about 1,000 beds in a hospital. All the patients are very sick and some of them crash because they're in the room. In addition to the ICU 150 patients, there are about 800 and odd patients in the rooms, but they're also sick. They can crash, develop cardiac arrest and so on. So every day in a hospital, we get about 6 code blues. Code blue, we have a code blue team, immediately they rush. And in code blue, generally it should be less than 4 minutes before you can revive the patient. If it's later, they don't get revived. So we should have an average 6 code blues every day, of which 3 of them could not be revived because of their time. And these patients didn't give an indication they're going to code blue. So 3 of them is to die, which means quite a significant number of very sick inpatient hospital patients to die. And we kept on getting these code blues disturbing us now. So what we did is we developed an algorithm with AI called the iSave. So what does iSave do? iSave takes 7 parameters, clinical parameters like the oxygen saturation, pulse rate, BP and all, which are normally recorded by the nursing staff. Normally they do it, but it's individually recorded. Now in iSave, all these records go into a central monitoring system and the patient reaches 5 points, that is 5 of these are abnormal. It warns our nursing staff and warns the medical emergency team that this patient is likely to crash in the next 1 or 2 hours. And our medical emergency team goes in and sees, okay, low BP, immediately correct the BP, some arrhythmia is coming in, correct the arrhythmia, and the patient does not require more fluid. 6 months back, we started iSave in our hospital using this, and we found in the last 6 months, we haven't had a single code. See what dramatically changed. Which means not only the hospital doesn't change code, but we are saving 3 patients every day using the system. So this is again something that AI has done. The other important thing is, and some of the surgeons here, like others should know this, that when we do surgery, we all have our patients who come for a checkup, pre-anesthetic checkup it's called. So and all of you know that we have a patient going for a major surgery, he has to go to a pre-anesthetic. And we do about 1,500 to 2,000 surgeries a month in a hospital. And we find that out of which around 300 patients were not coming back for surgery. You do a pre-anesthetic checkup, they don't come back for surgery. Dropout rates, which is there in all the hospitals, which varies. So in our hospital, it was significantly high. So we wanted to find out why. So we put our AI team onto that, and what they found is that a patient is asked to go for a pre-anesthetic checkup. He has to cover 17 points. Internal medicine, CT, pulmonology, cardiology, X-rays, waiting area, 17 points they go around. And finally, end of the day, they get a pre-anesthetic checkup done, but they're exhausted. They don't want to come. We'll see later. And some of them with, like gallstone disease and all can wait later also, because sometimes nothing happens after first attack. So this dropout is significant. So we asked, hey, what should we do? The answer AI gave was very simple. It said, create one tower where you get all the checkups in one place, so patient doesn't have to go. So my administrator said, oh, this is so simple, why do you require AI for this? We require AI because if we create one tower, this one tower should have all these investigations. We have, in fact, now we are starting to do CPET and so on, very high-end investigations for pre-anesthetic patient. All these should be in one tower, 17 points in one tower. We have to calculate the cost of creating this, the cost of personnel creating this, and so on, which is quite huge. But AI said, if you do this, you will not only create one place, you will enhance the image of the hospital because the patient is quite common, but your dropout rate will drop less than 1%. So then we created this pre-surgery lounge, which is very nice. Patient comes in morning 10 o'clock, finishes everything 12 o'clock, has some coffee and cookies and goes back happy. And the dropout rate is now our patients coming back to surgery is 99.9%. So you see, we saved this 20% dropout, actually saved money, one, and also they've enhanced the image of the hospital. So this patient goes and refers. If you have to get surgery done, go there because it's very easy checkup and you get a nice cup of coffee before surgery. So this has, again, another example of how AI is very different. Another area is endoscopy patient tracking system. We, of course, we are proud of our endoscopy rooms. We have 30 of them. We do 700 endoscopy procedures a day, one of the largest in the world. So
700.
One whole floor of 1 lakh square feet is devoted to endoscopy. So when the patient enters into the endoscopy room, he's lost. He's lost, the doctors know. Sometimes when a relative comes and asks me, my patient went for CBD stone, where is he? I don't know. The relatives don't know, the nurses don't know, so many patients, so much confusion. So this was creating a problem for us. So we again worked on this software. What we did is all our patients get a band, RF band, with RF trackers everywhere. So now when the patient comes in, he's continuously tracked. Wherever he is continuously tracked in a central monitor. And the patient's relatives also get a QR code, and they can continuously get a picture of where he's going and so on all the time. How long he's spending in which area. So continuous tracking with the patient. And this resulted in a chart that comes out like this on my cell phone, in the monitors everywhere. For example, I know which rooms are occupied, which rooms are vacant. Also, I know very clearly that the reception area, patient is waiting 5 minutes, it's okay. In the pre-procedure, 43 minutes, something wrong. So I push in more doctors, go to the pre-procedure, check the patient, send them quickly, procedure time, and past procedure, average half an hour, that's okay. So our aim is that at that time, if this is one of the key indicators of how endoscopy is practiced, the TAT time should be less than 2 hours. and now we reached 1 hour 30 minutes. We hope further it will come down once people get used. So this, again, another example of how AI has increased our operational efficiency. So that's health service management, and I think for the administrators here, these are important lessons of how we can increase the efficiency. This is just a small part, there's so many other things I won't have time to go through. Predictive medicine now. This is becoming extremely important. The way we practice medicine is changing, and I'll show you another example later on, but medicine is now becoming predictive. We don't wait for the disease to come. We predict what diseases are going to come and then see that how we can change. So this is going to be epidemic outbreak prediction can now be prevented by AI. In fact, when COVID first came, they didn't have this. 5 years back when COVID came, we didn't have the artificial intelligence capacity to contain the epidemic. Today we have. Just 6 months back, another COVID-like phenomena occurred in China. We may not even know about it occurred. They used AI and confined it to the rare virus, confined to that particular part of China. It didn't come out at all. It was because of AI. We have that capacity. We can, with AI now, actually monitor very carefully what is the movement of population, how many are getting admitted, what type of respiratory illness, are the illnesses matching in 2 different areas, everything. So using this now, epidemic outbreak protection is going to be a very important aspect of artificial intelligence. This is of course a governmental responsibility, but also a societal responsibility. And this is going to help us in how we treat our patient. What we did, we actually, again for doctors here, they know that when we read textbooks of medicine or something, they'll tell you, if you have a patient who's we treated, give 1 tablet of omeprazole a day or 2 tablets of BP tablets, Thelma a day, something like that. That's the standard treatment, we all write that down. What we haven't realized that there's a unique biological variation in every patient. These textbooks are wrong. Unfortunately, we follow because we don't have it. So every patient has a different metabolism, every patient is metabolizing his drugs differently. So what we did is we started a pharmacogenomic pathway with AI. Any patient coming to AIG who requires more than 4 drugs, anti-diabetic, antihypertensive, anti-ulcer drugs, more than 4 drugs, were then subjected to a pharmacogenomic study before they were actually started treatment. So they had, and when we looked at the pharmacogenomic pathways of these drugs, not only was there individual variation, some patients had a higher activity of CYP290, some patients had a lower activity of the drugs and so on, but there's also drug-drug interaction between drugs which we didn't realize, which was not in the books. And when we looked at it totally, 40% of our prescriptions were wrong, had to be changed. Some patients we had to give only 1 tablet of omeprazole for 2 days, some tablet 3 tablets, so it is totally different. We changed the prescription in 40% of the patients. And we realize now that, so now we offer the patient, if you come in, you get a pharmacogenesis, it's cheap, it's only 5,000 rupees. We already have the software. We just send this paper to New England Journal because we are one of the first hospitals to practice this. And we can modify it. So this pharmacogenomics pathway is for the rest of the life. It doesn't change. We modify it. Once you have this, you go to any hospital, you can show your doctor, this is how I'm going to react to this particular drug, and then you can give the correct dosage. So in future, our drug prescriptions are going to be based on AI, especially if multiple drugs are taken. We should use AI for better prescription and not follow blindly all the textbooks that are talking about. And I talked about all these large language models. Now, small language models. Small language models are also very easy to use, and this is an example. One of our hepatology group have come up with this. Of course, Dr. Sharin is here. NAFLD is his passion. NAFLD is extremely common. I think 40–50% of the population. But there are various degrees of this that are there. Large. The standard diagnosis by using a fibroscan, which will tell you what is your steatosis and what is your fibrosis. That's the standard. Fibroscans are costly. They cost 1.5 to 2 crores. The test costs about maybe 5–6,000 rupees. Can't be done in rural areas. Everywhere it can't be done. So is there another alternative way where you can actually predict accurately what is the fibrosis and steatosis? So we developed this algorithm where, I'll show you the algorithm here, where we can now take 4 major blood tests and 2 small blood tests. These are simple tests. LFT, platelet count, CBP and so on, and then using the age, BMI and all, make an estimate of the fibroscan. FIB4 is used but only for fibrosis, not good for steatosis. But we want for both. So then we have what is the prediction based on this test. And this algorithm tells us, for example, this patient fibroscan was, his steatosis was 277, fibrosis was 6.2. And when we compared with what happens when we use our algorithm or only blood test, and you can see here 270, 277, 6.8, absolutely almost nearly same. We validated this in 30,000 patients and plan to do this in another 100,000 before this can be out in the open market or something. So this will cost you about maybe 200-300 rupees. Can be done in any small village anywhere. And of course, this accuracy is so high now, we can probably replace, at least in some areas where it cannot be done, fibroscan using the simple algorithm. Again, a classic example of how AI is making healthcare equitable. Equitable because it's available in rural areas, equitable because the cost comes down by 1/10 using this technique. So this is regarding, this third aspect is patient data and diagnostics. This is again something which we're using quite a lot of AI. For telemedicine, of course, for other things I told you about. But the most important thing is the natural language processing and notes. Now, medicine as we practice today is completely changed from medicine what we practiced 30, 40 years back. Because we now see the patient and say maybe I have 20 minutes with the patient, 18 minutes I'm spending looking at the computer, typing, because electronic medical records, we want everything there. So we do these things. And eye contact with the patient has gone down to 2 or 3 minutes. But we know this is not right. Our patients get better with a lot better eye contact, talking to them longer and so on. But we are not doing this. We are not doing it because we are worried about EMR, which is very important. We are worried about it. So what we now developed is something called the PRISM. And let me again show you an example. This is the PRISM, the Prescription Recorder Intelligence Summary. I'm looking at the patient all the time. I have a computer with me which is recording what I'm talking to the patient. And I'll give you the actual speech. You should excuse me for my Hindi, but
क्या तकलीफ है मनीष?
सर पेट में बहुत दर्द हो रहा है सर एंड इधर बहुत क्या पेन आ रहा है सर।
ये कितने दिन से हो रहा है?
सर 2-3 मंथ से हो रहा है सर।
2-3 मंथ।
यस सर।
और जो जलन हो रहा है ज़्यादा छाती में?
यस सर, ज़्यादा हो रहा है सर।
नाजिया या वॉमिटिंग है?
यस सर।
फूड फेस अच्छा है?
यस सर।
फूड ठीक है?
यस सर।
और मोशंस का कोई प्रॉब्लम है क्या?
मोशंस नॉर्मल सर।
सूज नॉर्मल।
यस।
कुछ प्रॉब्लम्स है पास्ट में, कुछ डायबिटीज या
नो
बीपी का तो नहीं?
नो सर।
हाइपरटेंशन।
नो सर।
ये प्रॉब्लम जो है ना,
यस।
वो आपको कुछ पेरेंट्स को भी है?
यस सर, मेरे पेरेंट्स को भी है सर।
पेरेंट्स को भी आंसर था?
यस फॉल्स सर, यस सर आंसर।
So Rajesh, your diagnosis looks like peptic ulcer. So we'll have to do endoscopy and ultrasound. For that, I'll start your medication, pantoprazole 40 mg daily. Once we do endoscopy, we'll give you time.
so I just click a button after everything is over here on the screen, and then I get a complete recording of what I've talked in a segmented form. This is NLP. See that I have a diagnosed medication, past history, lab orders, everything. So I have not done anything to type. I've just talked to the patient. The NLP has managed to convert this into a nice medical notes in ordered fashion. And the most important thing is it can take 4 languages, Hindi, Telugu, Bengali and English. We are developing more languages. Other second important thing about this, any gossip you talk with the patient, have you seen Pushpa movie or something, doesn't get it. It filters the gossip, that's intelligent. So that's so you can be very free with your patient. So this is something we are now used. We have validated this in 100,000 patients now. We are using it in all the different clinics, cardiology, everybody is using it. And once we reach a point that we're confident that it's going to give us very accurate segmented short form like this, then we like to give it out to all the hospitals around the country. So that everybody can use it, and all of us can now develop an uniform way of EMRs so that we're interoperability can complete. So this is another revolution that's going to come. So another area where we're going to use this quite a lot is in data integration in patients. And again, I'll show you some examples. In this was a patient I saw recently in a hospital who came with abdominal pain and so on. And when we actually did a CT scan, there was a tumor in the head of the pancreas. It was a bit of biopsy, pancreatic adenocarcinoma, infiltrating into the vessel, not suitable for surgery. This patient has been coming to me for the last 3 years with some vague pains. And 3 years back, he had a CT scan done for the pancreas, reported normal. So I just fished out the old CT scan and gave it to a head department, Dr. Tarini, extraordinarily bright pancreatic radiologist, and asked her, how is this scan? She said, this scan is normal. 3 years back, scan was normal, totally normal. I then got the scan and sent it to one of the top radiologists in the world at the Mayo Clinic. We have a tie-up with Mayo Clinic, so I sent it to him and said, can you see anything in this scan? He saw the scan and he said, it's absolutely normal. 3 years back, the scan is absolutely normal. I then took it and we are now developing an algorithm in our department for pancreatic cancer. I gave it to our AI. The AI saw this and said, this patient is likely to develop pancreatic cancer in a few years' time. This was astounding. So AI saw certain patterns in the CT which human eye could not see. It could make out. This is an unexplainable AI. Of course, we are not fed it about it, but it's able to come out. In fact, there's a very interesting study from the Mayo Clinic which looked at people around the Mayo Clinic in the county there, and they're starting to take ECGs and trying to do some AI thing with ECG. And suddenly, the AI came up saying, in patients with ECG, saying this patient has chronic liver disease, this patient has NAFLD, this patient has got hepatocellular carcinoma. All that, just ECG. They were, the people who are working there, the AI engineers were actually totally surprised. And now, then they said, how can this be possible? Because they haven't trained the AI to do this, but AI was able to do this. So this is unexplainable AI. So the potential side effects are going to come. Things like this are going to happen as we progress, and I think dramatic things are going to show up in future. So this was probably, if I had this facility 3 years back, I would have saved this patient from this in terms of at least getting early surgery done. A lot of AI devices are now coming to market, and this is an example of a very intelligent bed that we got for our ICU. Now in this bed, when the patient lies down, normally intelligent beds will tell you about the weight, height and so on. This bed, when patient lies down, will tell you about the height, weight, temperature, the oxygen saturation, it will tell you about the sodium, potassium, calcium, everything. Very intelligent bed. When we use drugs along with this bed, when we put in some drug, it interacts, there's an interoperability between that. So suppose patient has hypotension and putting fluids, giving epinephrine in that, it will actually adjust the dose. It says this is not enough till the BP comes to 120/80 and then it will stop, decrease the dose. Very, very intelligent. Now, when we got this bed, very expensive. It was very expensive. Our administration said, no, what is this? This is expensive, you can't do this. I was being adventurous and said we'll try it out. But then what we found was that now in our ICUs, for every bed we have 2 nurses. 2 nurses for every bed. This is normal now. In this case, we found once we started intelligent beds, 1 nurse could manage 5 beds. So therefore, long term you save the cost. So this is another example of how. There are of course dangers. In fact, there was one bed like this in Germany, a Russian opposition leader was admitted, and the hackers could hack the bed and gave wrong dose of the medicine and person. So this is the danger there. Of course, that is not for us a major concern at present at least. So this is another thing, and then clinical decision making. Again, there's a huge difference. I'm a gastroenterologist. I look at endoscopy and then say this is a polyp, benign polyp, this is a malignant polyp and so on. And we have now a very mature system called CADI and so on, which diagnoses these polyps. It took me 40 years, and Ajay will also tell you this, it took us 40 years to actually develop all this knowledge to say benign polyp, malignant polyp, and so on. But with this now, junior resident just put in an endoscope and say benign polyp, malignant polyp. So he didn't require the 40 years of knowledge and experience. The problem there is that are we de-skilling our younger doctors? Are they losing their skills because of this? So this is another problem, but anyway, this is what has become very commercially now. 80% of hospitals in the United States have this so-called Genius or other systems in their endoscopy systems to detect this at a very early stage, and they use it for not only polyp detection but also for to prevent interval cancers and all. But now we also started using, this is a procedure called OM. We do this little risky procedure, third space, I go in, you can see I'm cutting the submucosa there to cut the muscle in patients' achalasia cardia. There's a blood vessel coming there. Earlier, many times they're cutting the blood vessel by mistake, but we now developed this new AI system. The AI is telling you stupid, there's a blood vessel, do prophylactic coagulation before going on. So I watch, I do a prophylactic coagulation, then I cut. And using this system and compared to non-AI procedure, we found that you decrease the number of complications, you decrease the time spent. And this algorithm was developed within a week, 1 week by engineers. So easy. It's not very difficult thing. So these are some things that we are starting using. I think in surgery also now we have navigation systems which are superimposed on our CTs, MRI with AI. Now you can do much safer, faster, and more complicated surgeries. And this is more interesting. With computer vision, this is a paper in Nature in 2017, long back. See, the next sentence is there. This was a patient who came with a nodule in the skin in New York. This is a very interesting paper for you to read. 25 top New York dermatologists were asked to see this patient and make a diagnosis. And each of them gave a different diagnosis. Melanoma, carcinoma, tuberculosis, granuloma, growth, and so on. All of them gave a different diagnosis. The computer vision AI was used on this, and it said, this is amyloidosis of the skin. Nobody has seen amyloidosis of the skin. These 25 dermatologists, such famous people, hadn't also seen one like this. It said amyloidosis of the skin. So they said maybe something wrong. AI can do what's called hallucinations. It can completely go off the track, so maybe something. So they took a biopsy and sent this biopsy to the pathologist, and the pathology report came as amyloidosis of the skin. So you see, AI saw something which nobody else saw. So I think what's going to happen, at least in the field of dermatology, is AI is going to completely take over. My wife is here shown like this, but I think the field of dermatology is going to slowly disappear because AI is going to take over. It's happening to some extent radiology. Now in our hospital, 50% of the X-rays are read by AI, not by radiologists. The radiologists, they don't like to see X-ray chest, they don't like to see variants and all are read by AI now. AI gives us a diagnosis. Only when I have a doubt, I'll send it back to a radiologist, kindly have a look. So AI is going to take over now, completely. And this is another interesting concept also. These are mobile devices which are going to take over now. I don't know how many of you are wearing mobile devices, smart watches, smartphones, and so on and so on. Here, AI is playing a role because it can interconnect all these devices. And I'll show you an example here. I have of late become not only a fitness freak, but a predictive health freak. I'm trying to look at my body to see how the functions are going. So I'll show you the example of how this. But AI is moving so forward that this month in January, I was asked to give a talk on AI and microbiome in a World Congress in Hong Kong. I made this slide where there's a smart toilet. You actually do your job on the smart toilet, and the toilet comes out with analyzed microbiome analysis is done, and then it says that microbiome analyzed, AI is applied. Today you need more calories, increase sleep, and that sort of thing. In Japan, this is being done for urine for many years, but now with the students. So I thought this is futuristic. Let me show this to you. I went to this conference, and as I was entering into the main conference hall, already they had this toilet. They sit on this, it tells you today this is your brain function. It's got a small chip at the bottom which checks your stool. And then tells immediately this is your brain function today. be careful when you're talking because the brain fog is going to come things like that. So it gives you all the, so this is now getting commercially available. The stool becomes very valuable because stool contains hundreds, thousands of microbiomes, each of them different activity. So don't just throw it away, get them analyzed and then you grow. And this is, as I said, my personal interest. Today, as I'm standing here, I have a smart watch, I have a smartphone. I also have two other devices attached to me, which are measuring my serum cortisol, which is measuring my IL-10 and IL-6. I also have a VO2 max continuously measured by watch. So these are all health parameters that I'm measuring. Every Sunday I get my gut microbiome also. All these are integrated onto the cloud and they're being continuously sent. Even as I speak to you now, they're being sent to our AI server at AAG, which has got my basic NGS genomic analysis already done. It's interacting. The devices are interacting, my NGS genomic, all are reacting to billions of data points are being created. So maybe after we analyze this in 3 months or 6 months time, I will know what's going to happen to my health. This is a predictive health. This is going to dramatically change how we look at disease. The WHO definition of healthy person is not having disease is wrong. This is totally wrong. A healthy person is your health, genomic health, metabolic health, microbiome health. These are the health. And now there are a group of scientists all over the world doing this where you're measuring your own metabolic parameters continuously, and this is again a combined project we're doing with the National University of Singapore, where some of them are also doing. Continuously get all data together and predict your health based upon. At a particular point, how is my microbiome show related to what is happening to my metabolic health, cortisol levels. I'm speaking today here, there's some stress, cortisol will go up, IL-6 may go up, IL-10 may come down. All these parameters, how they are correlated. So we are going to get billions of data, and we cannot analyze this data unless we have AI. AI algorithms are going to come, we're going to analyze this data, and again, we're going to change the way we practice medicine using all this. So one of the objections I had to AI was AI is very mechanical, you tell the patient talks, but even Meera, a little mechanical. She's good looking, but a little mechanical. So we wanted to see whether AI is better. And this is very interesting. This study, published in JAMA Internal Medicine in 2023, was a very interesting study where patients who were discharged and went home were asked to call back the hospital and talk to the doctor who treated them, or ask questions like, usual questions where I have an extra stool today, I had some gas today, that type of, they're all calling back and asking. A randomized trial was done comparing doctors to a computer who was listening to these complaints and talking back. So it's LLM and NLP together. And what the study found was that the patients found that the computer was more empathetic than the doctor. So the final straw that we are better than computers in terms is gone. They are better. You can train a computer to be very empathetic. You can train whatever you want, but it can become very empathetic. You can train a computer to, if a patient is asking very silly, rash questions or irritating, you can train a computer to also be stiff with the patient. So all these things can now be done because of the ability in AI. So this is just a snapshot of what is happening in this area, that I think AI for individual health, a lot of lifestyle changes like I showed you, we can monitor everything. They can tell us how much to eat the next day, how much exercise you can do the particular day, and so on. Sleep has become a very important part of AI. Sleep analysis. AI sleep analysis is a separate subject by itself. There's huge things coming in that area. Interpretation of lab results. Now again, interoperability. You just don't look at blood sugar, A1C or urea creatinine. All the results are integrated to give you a total metabolic health. That is part of AI. Of course, clinical diagnosis. And also AI can monitor compliance, so the patient is taking medicine or not, what is happening, all those things. I think this is a huge thing, and of course, drug development is going to be the future of AI. I think all the pharmaceutical companies are now going into this AI drug development, and you can see a marked change on how we can actually win. And this is where we in India can make a dramatic contribution. Because these drug development algorithms are made in small labs. Other day I was in a small city in Maharashtra. There were two scientists who came back. We were sitting down in a small room like this and making algorithm for a new biological drug. You can sit in a house, small, you don't require much infrastructure. And we Indians are very bright in this. Engineers can come together and do drug development. And then, of course, you pass it on to bigger companies. So this is going to be a major thing that's going to come up. But having said all this, there are also challenges. Which the most important thing that people don't realize is AI is as good as the data you feed it. Your data should be pure. Your data should be good. Otherwise, you get bad results. This is extremely important. So data is very important. There's ethics also concerned. There's a problem now, ethics and regulatory problems. There was a recent case in the United States of a colonoscopy where actually the gastroenterologist did the colonoscopy using AI. He missed a polyp, which was later on picked up by another place. So the patient sued the hospital. The hospital said, not our fault, the AI fault, sue the AI. Now, where did they sue the AI? Then they went to the court, and the court said, it's not AI's fault, it's doctor's fault, you can write now. But in future, as AI gets more and more sophisticated, we are doing, colonoscopies without even people there, only AI, it's going to be a big issue. We don't have regulatory mechanisms. And this is a problem which our country is facing right now, which most countries are facing. They are now struggling with this. How to set up regulatory bodies which can monitor. We have regulatory bodies for clinical. If you do something wrong clinically, then of course we have committees and all. But for AI, there's no regulation. And this is going to be a major problem. Our government has to come up immediately with processes where AI in healthcare, we have AI in agriculture, AI in healthcare has to have regulatory bodies so that unethical things are not done, or if problems occur, who is responsible for that? This is one of the problems. And of course, AI, as it grows and grows and becomes much more common, you're going to have many, many challenges. And one of the challenges that are going to come is with cyber security. November last year, I think all of you know that AIMS was hacked and the data was taken out. The fact, of course, problems, you may have data from high-profile people and all, that is different. But there's something very interesting I learned at that point in time, that I think about 40 million bits of data were taken from AIMS. In the dark web, there's something called the dark web. You can sell the data. In the dark web, if you sell a credit card, you get $10. Stolen credit card gets you $10. In the dark web, if you sell one medical data, it gets you $250. The medical data is so valuable. Because of the value, because of the economy involved, people are now going to try to hack into different systems. So cyber security is going to become a major problem for the government, for agencies and all, which has to be regulated. Again, having said all that, I think, let me come to a little nihilism or skepticism. In 2015, Elon Musk said that self-driving cars are going to become so common that everybody will be using a non-driver car. It's going to be a driverless car. In 2016, a famous radiologist said the way radiology is developing AI, radiologists will become absolute. But 2025, our radiologists are driving to the hospital in their own cars and coming and reporting. So some of these AI predictions may not be absolutely true. We'll have to wait and see in some areas, but they are going to make differences. So artificial intelligence in health is a major topic now. In fact, Government of India has identified 3 important areas: agriculture, education, health, and health first, where they're going to apply AI. In fact, there are several pros before this. You cut the treatment time, better disease diagnosis, unnecessary hospital visits are made, and then of course create administrative efficiency, which you can't do normally. Tremendous efficiencies, hospital efficiencies increase by 40–50% if you put AI into your systems. There are problems like initial capital investment is very high. I didn't realize this. We actually started a department of artificial intelligence in a hospital, employing about 40 engineers from Google, Microsoft, and so on. And then I discovered that the salary of these engineers is much higher than average salary of a doctor. So they're very expensive. The second important thing I tell you is the amount of electricity these AI machines take up is huge. 10 times more than what a CT or MRI does. Extremely high. So your power efficiency, power cost, all goes. So there is a cost involved. But I think long term, as you go along, this is going to change. Efficiency will overcome the cost that we spend. And of course, I think one of the advantages we have in our country is a large amount of data. Data is gold. So many companies all over the world, AI health companies contact us. We want to collaborate. Initially, we are very thrilled. Company MIT, we want to collaborate with them. Then we realized they don't want, they want the data. So that's the reason why we should be very secure. We should do our own things in the country. We should not give out our data to others. Because data is our strength. Data is gold. And we can do many things with data. In fact, it's believed that in future, AI is going to be the main economy driver. And I think most of you must have known about this Neuralink, which Elon Musk actually made. So his concept was to make these small, very, very tiny chips with over 1,000 threads to it. This kept in different parts of the brain. And now it's being done by robotic. Initial stages it was a surgeon. And then the brain now commands each part of the brain without the need. Suppose the brain, somebody has a paralyzed hand. Now with this thought, he can say, I want to lift my right hand, the right hand gets lifted because it's connected now using this AI system. 3 patients have already been done and it's quite effective. Of course, there are some issues with that and it'll take some time, but I think this is again going to be an example of how AI is revolutionizing healthcare. So as we evolved in evolution, you can see that economy was initially agriculture in 2000 years back, then it became military. World War I and II and provided huge amounts of economy to many countries. Then it became trade, trading, and of course that's getting to problem now. Trade became major, and then technology. Technology is one which drove the economy of the world. But now I think we're shifting. We're shifted from first power, mass production, compared to now the economy of the world in 21st century. And this is a prediction everybody, all the economists give, is going to be artificial. And ladies and gentlemen, it's here that our country can now be a leader. We couldn't get into mass production, we couldn't get into steam power, we couldn't get into computer because all this required infrastructure. Infrastructure which is very expensive, we couldn't afford it in developing countries. Whereas with AI, you don't require, you require men capital, you require people who are intelligent. You don't require large amount of money to put it. And we have that. We have extraordinary engineers, doctors, youngsters who can come together and create. And that's why the world is looking into India for this AI, especially AI in healthcare. In fact, that's the reason why we started this Center for Artificial Intelligence in our institute. We have 40 AI science engineers working with our doctors. And some of the examples I showed you, many, many more are there we are creating for operational efficiency. In fact, we started this course with ISB every year. Those youngsters interested can join. We do a combined course with ISB on AI in medicine. It's actually very oversubscribed. For next 2 years, it's full, where we teach young doctors for a period of months and then give them workshops to not only learn AI, but create small AI for their own hospitals. And in fact, just this month, Government of India has come out with AI mission, India AI mission it's called. Government of United States put $500 billion last month in February to create a new AI, most of it on healthcare. Immediately the government of France came and said $109 billion. Indian government has come up with $1 billion, 10,000 crores for this. So when I was asked from the Ministry of Health whether this is okay, I said, in $1 billion, we can create 1,000 times more than what United States can do, 500 billion. We have the capability, the costs, we can do what all we created. For example, I show you in terms of MIRA and so on, our polyp detection rates. We created a polyp detection rate at 1,000 the cost of what was done in Western world. We can do this. In fact, you can see the second point, India Innovation Center. They have about 300-400 crores given to that. 5 of us as a consortium now have come together to create many predictive models for diabetes and NFL and so on. So I think we have an extremely bright future. I think even the government looks at it in a very good way, and I think that the economy is going to dramatically change there. In 2010, people who have been to US will realize when there's traffic lanes going on, you have these people, pilots, going to all the roads and telling you this NH is blocked, take another pathway, take another 2010. In 2019, this was totally replaced by drones. There were no more helicopters and pilots. The drones replaced traffic regulation in the United States. So just in 10 years, both the man and pilot lost their jobs. So I tell again our people that you won't lose your job. The doctor who knows AI is going to be better than or replace doctor who doesn't know AI. Remember that you have to be AI knowledgeable now in future. And finally, ladies and gentlemen, I think this is a very important observation that Charles Darwin made. It's not the strongest of the species that survives, not the most intelligent, but one most responsive to change. The time has now come for our country. We don't have the might of the United States, or we don't have the skills, technical skills of Europe or Japan, but we have the mindset to change. With this, we can now become leaders in artificial intelligence in healthcare, mainly because we have the data, we have a lot of very intelligent doctors, engineering coming together, and I see a future which is very bright for our country in this area. Thank you very much.